welcome to my channel. So in this video I'm going to briefly go through the solution to this specific question called a boundary of binary tree, and also at the end of this video I'm going to briefly go through the general steps we should follow in a real interview. So let's get started. Before we start the real content for today, I would really appreciate that if you can help subscribe this channel, because this can help me to grow. Thanks a lot. Let's read through this problem. The boundary of a binary tree is a concatenation of the root, the left boundary, the leaves ordered from the left to right, and the reverse order of the right boundary. So the left boundary is a set of the nodes defined by the following. The root's left child is in the left boundary. If the root doesn't have a left child, then the left boundary is empty. So if the node is in the left boundary and has a left child, then the left child is in the left boundary. If the node is in the left boundary and has no left child but has a right child, then the right child is the left boundary. So the leftmost leaf is not in the left boundary. And then the next thing is the right boundary is similar to the left boundary except that it is the right side of the root's right subtree. And again, the leaf is not part of the right boundary. Okay, so the leaves are nodes that do not have any children. So for this problem, the root is not a leaf. Okay, so given a root of the binary tree, so return the values of its boundary. So let's take a look at this example. For this one, this is a root, so this is the right boundary. Those two are leaves, so there's no left boundary for this one. And for this one, the left boundary is this and this. So this is the left boundary, and this is a leaf node, leaf node, leaf node, leaf node, leaf node, and this is a right boundary, and this is a right boundary. So I think that's pretty much it. Let's see the constraint. It says that the tree is never going to be empty, and the value is between minus 1000 to 1000. So the general solution is to do a pre-order traversal of the tree. So let's go through this piece of code together. So the general idea is to do pre-order traversal, and during the traversal, there is some special things happen. So for example, the first special thing is we need to tell whether the node is left boundary, right boundary, etc. And the second thing is we need to, if it is left boundary, we add it to the corresponding list. If it's right boundary, we add to the corresponding list. And if it is leaf node, we also add to the corresponding list. So those are the two special things. We just tweak the traditional pre-order traversal. So let's go through this piece of code. We define this function boundary of binary tree passing the root node here. We define three things: the left boundary, right boundary, and leaf. And we define this helper DFS helper function. And also we have a other helper function, which is merge boundary. So let's first see the merge boundary stuff. We have the left boundary, right boundary, and the leaves. So we are going to add all the stuff from the left boundary, add all the stuff from the leaf, and then reverse the right boundary and add everything from the right boundary to the boundary, and then return. So that's very simple. So let's see the most juicy part, which is the DFS helper function. So we have the root as the first parameter, and then it's whether it is left boundary, whether it's right boundary, whether it's a root node, the left boundary integers, right boundary integers, and the leaves. So the first thing we see whether it is a leaf node. So if it is a leaf node, then we are just going to directly add it to the leaves, regardless whether it is left, right, or it's root, whatever. So we are just going to add it to the leaves. So if it is a root node, then we will just add the root node into the left boundary, because the result is going to be the same. So we treat the root node, we add the root node value into the left boundary, and if the left node is not a non-pointer, then for sure it is going to be a left boundary. So we are going to called DFS, set the is left boundary as true, and then we pass in everything else into the DFS. If the right thing is not none, then for sure the right node is going to be a right boundary, so we are going to set its right boundary as true, and then we just return. So this is its root. So if the current node is a left boundary, as said, if the left node is not none, then for sure it is going to be the left boundary, so we are going to set the left boundary as true. And also we need to add the node value into the left boundary. And if the left is not equal to none, we have the left boundary, so the right one is like in the middle of the tree, so it's neither not left boundary or right boundary, so we are going to set everything as false here. So if the left is equal to none and the right is not equal to none, then it means that the right node, the right child is the left boundary, so we set this as true. Otherwise, if it is a right boundary, so it's like the reverse way we write this piece. So we will say, okay, we add it into the right boundary, and if the right is not equal to none, then for sure that the right thing is right boundary, so we set is right boundary as true, and at the same time we need to we need to traverse the left child, but the left child is just in the middle of the tree. It's neither left boundary or right boundary. But if the right is equal to none, but the left child is not equal to none, then the left child is the right boundary. So we set that is right boundary for as true, and we do the DFS traversal. Otherwise, if the current node is neither left or right boundary, we just set everything as false. Just treat it as some node in the middle of the tree, and then we just continue the traversal. So that's pretty much it. The runtime and the space-wise both are going to be all of n. So n is the number of the nodes within the tree. So let's talk about the general steps we should follow in a real interview. So in a real interview, the first step is always try to understand the question, ask some good questions to clarify if there is anything you don't understand, and also at the same time think about the edge case. So remember, don't jump into the coding part too quickly, don't directly start coding, so you still need to have some communication work with your interviewer. And the next step is about finding solution, think about ideas, talk aloud, and explain the runtime space analysis, and also get an agreement with your interviewer about the approach before you start coding. And then you start coding, take care about the speed, and also make sure about the correctness and the readability of the code. And also at last, after you're done with coding, please definitely do some testing. So that's pretty much it about this video. So if you like this video, please help subscribe to the channel. If you have any question, feel free to leave some comments below. I'll see you next time. Thanks for watching.